Good morning, good afternoon, good evening, wherever place you are watching me from. I want us to look at the last bit of that is differentiation. And specifically, we are going to look at maxima and minima. Now, let us consider this question in maxima and minima. The question is, a farmer has 100 meters of wire mesh to fence a rectangular enclosure. What is the greatest area he can enclose with the wire mesh? Now, this is a question of application in the topic of differentiation, and specifically it is from maxima and minima. It is asking us to find the greatest area the farmer can enclose with the wire mesh. Now, this is a rectangular enclosure. So, we need to represent this information on a diagram. Now, we need to draw a rectangle that has a length and width. Now, this is a rectangle. This is a sketch of a rectangle. Now, we can say if the wire mesh is 100 meters long, we can say that let the length of this rectangle, of this rectangular enclosure, let the length be, let's say, x meters, because the rectangular the wire mesh is 100 meters long. Therefore, we can say let the length be x meters. Now, if the length is x meters, then what will be our width? Because the wire mesh is 100 meters that should fence this rectangular enclosure. Now, remember the perimeter of a rectangle. The perimeter of a rectangle is always 2 into length plus width. Now, perimeter is the total length of the enclosure, and the total length of the enclosure is 100 meters. It is 100 meters, which is equals to, that is 2 into length. We have let our length to be x plus width. We don't know our width. We need to know it. Now looking at our question, that a farmer has 100 meters of wire mesh to fence a rectangular enclosure. What is the greatest area he can enclose with the wire mesh? Now, we have represented our question on a diagram. We have represented it on a diagram. As we can see on our diagram, that we have this rectangular enclosure that has the length as x meters. We have let the length to be x meters. And we have said that the perimeter of a rectangle is 2 into length plus width. The perimeter is the total length of the enclosure. And the total length of the enclosure is the length of the wire mesh that the farmer has. Now, the length of the wire mesh is 100 meters, which is the perimeter, equals to 2 into length. Instead of length, we substitute with x because we had let our length to be x meters. So it will be 2 into x plus w. W is our width. We don't know our width. Now, we need to know it. Now, at this point, we can divide by 2 on both sides so that we can eliminate this 2 that is on our right. Now, by 2, 1, by 2, this is 50. Now, this is 50 equals to x plus w. Now, we need to obtain w, which is the width. Now, in this case, we shall have to take this x to the other side, and therefore, to make w the subject, we shall have our w as 50 minus x. That is 50 minus x. And this is the width that we have, that is 50 minus x meters. And therefore, on our diagram, we shall have our width as 50 minus x, that is meters. Now, we need to find the area of this rectangular enclosure. Now, the area of a rectangle is always length times width. The area of a rectangle is always length times width. Now, our length is x meters, and therefore we shall have x times, that is our width, which is 50 minus x. Now, from there, we can have our area as, if we expand this, we shall have x times 50, which is 50x. Then x times negative x, which is negative x squared. Now, that will be our area. That will be our area of the rectangular enclosure. Now, since this is our area, then we can say that at maximum or minimum area, that is at maximum or minimum area, at maximum or minimum area, our dA over dx is 0. That is, dA over dx is 0. That at maximum or minimum area, dA over dx is 0. That means we have to differentiate A with respect to x. Now, this implies that our dA over dx equals to, now we have to differentiate A with respect to x. And if we differentiate, then we shall have, if we differentiate 50x, then we shall have, that is 50. And if we differentiate negative x squared, we shall have negative 2x. Now, our dA over dx is 50 minus 2x, which we have to equate it to 0. That is at maximum or minimum area. Now, that means we shall have, that is 50 minus 2x equals to 0. Now, what is the value of x at this point? Then we shall take 2x, that is negative 2x on the other side, and it will be positive, which is 2x equals to 50. And if I divide by 2 on both sides, then I shall obtain my value of x as by 2, 1 by 2, 1. By 2, 1 by 2, this is 25. And therefore, the value of x is 25. Now, we need to know whether when x is 25, our area will be maximum or minimum. We need to know whether we shall have a maximum area or a minimum area when x is 25. Now, I want us to consider this table. And considering this table, we shall have our x dA over dx and a diagrammatic representation. Now, this table will have 25 at the center here. Then, to the left of 25, the number that is to the left of 25 is 24. And the number that is to the right of 25 is 26. 26. Now, we need to determine our dA over dx when x is 24 and when x is 26, because when x is 25, we already know that our dA over dx is 0 at this point. Now, we need to know that at the point when x is 24, what will be our dA over dx? That means what will be our gradient at that point? Now, when x is 24, what is our dA over dx? It will be 50 minus 2. Instead of x, we shall have 24. Now, 2 times 24, we shall have 48. 50 minus 48, it is 2. It is 2. Now, when x is 26, what will be our dA over dx? It will be 50 minus 2 times 26. Now, 2 times 26 is 52. 50 minus 52 is negative 2. Now, at this point, the diagrammatic representation will be, this will be positive, this will be 0, and this will be negative. And therefore, at this point, we shall have a maximum area. When x is 25, the area is maximum. And since when x is 25, our area is maximum, then we shall substitute the value of x equals to 25 in our original area. Our original area was, that is 50x minus x squared. So instead of x, we shall have 25, and therefore we shall have our area, which is 50 times 25, then minus 25, that is squared. And now at that point, 50 times 25 is, that is 1250. Then 25 squared is 625. And therefore, if you minus, that is 1250 minus 625, then you shall obtain, that is 625. And since it was in meters, then it will be square meters. It will be square meters because the area will usually be in square units, and therefore this one is 625 square meters, and that is the maximum area of the rectangular enclosure that will be fenced by the wire mesh